Hi, let's implement Quicksort using Python and Hoare Partitioning. While I'm typing out the outline of the program, let's discuss the Quicksort algorithm itself. Quicksort is a divide and conquer algorithm which selects a pivot element and moves all the smaller elements to the left side of the array and all the greater elements to the right side of the array, and then calls itself to both these segments recursively until the segment sizes become smaller than a predefined threshold. Now that I'm done with the recursive shell of the algorithm, we can start working on the partitioning scheme. In this implementation, I will use the middle element of the array as the pivot. This is an arbitrary choice and there are better choices than this. I will not go into details in this video. Next, we will have to go through the array and build the segments that have the smaller and greater elements respectively. I will use two variables, I and j. I will go from the left side and j will go from the right side of the array, and both of them will skip all the elements that are in the right order and stop on the first one that is in the incorrect order. I will increase until it finds elements that are smaller than the pivot, and j will decrease in value until it finds elements that are greater than the pivot. Once these two loops terminate, we either have I and j as the same value, which means we don't have to do anything, or they are different values, in which case we have two elements that are in the wrong order and we need to swap them. I also put a log line so that we can see in the output window what is going on. Once we have the element exchange, we can see that the program runs the success sorting the array as we expect it to be. And here we go. As you might have noticed, all the elements in this array are unique. What happens if we put a duplicate element? Let's say I add another 5 to the end of this array. That didn't go so well. This is something easy to miss with Hoare partitioning. When you make a swap, you have to make sure that the indexes are incremented and decremented respectively to prevent this infinite loop from happening. Now that we have sorted out the partitioning scheme, we can start optimizing our code. First of all, let's try to decrease the number of quicksort function calls. We can safely say that if there is no at least two elements in the segment that we are about to sort, we don't really need to do anything with it. And here we go, the exact same output. One more optimization we can do is stop using function calls at all. Instead of relying on the system stack, we can provide our own stack. This could be a simple list of tuples in Python because it provides all these stack-like methods on it. So we just need to add another while loop that checks if there's still more segments to run the quicksort on. It pops them and then just calls the exact same code that we were using until now. And instead of calling the function, it adds the next segment to be sorted onto this stack. This is it. Thank you very much for watching and see you in the next one.